So first thing first, you have to measure 4.8 gram of sodium hydroxide. 4.8 gram of sodium hydroxide. Here is my sodium hydroxide. Here is sodium hydroxide. So let's quickly measure 4.8 gram. Then, so you put on your device. Put on your device. Let's put it on the ground. So place your picture paper. So this is 0.8 plus. Okay, now my filter paper is giving me 0.8. So you add your 4.8 gram. You know you have to. I said measure 4.8 gram of sodium hydroxide in it. So this is 0.8 plus 4.8. So I'm having 5.6. So I have to quickly then you carefully add till you get 5.6. Let's get 5.6, and let's be fast because sodium hydroxide is a deliquescent salt. 5.6. Let's be as fast as possible. Okay, that's 5.6. Sodium hydroxide is a deliquescent salt. When exposed to the atmosphere, it absorbs water molecule. Okay, I'm done with solution B, that is the base. I'm done. What I just did was to measure 4.8 gram of sodium hydroxide in 1000 cm cube of the volumetric flask. First of all, I fill it with water. Add your 4.8, shake it until it dissolves. Then you now fill it to this mark. There is a mark here. There is a mark here. Once you get to your school chemistry laboratory, look for this volumetric flask. Look at it, you are going to see a mark. That mark makes it 1000 cm cube, which is equal to 1 dm cube, which is equivalent to 1 liter. So now let's quickly prepare our solution A, which is the acid. Then for the acid, you are going to use your measuring cylinder. So I will be using this is just 10 ml measuring cylinder. So I will be measuring 9.0 cm cube of concentrated hydrochloric acid. 9.0 cm cube of concentrated hydrochloric acid, that is HCl. So the reaction is going to be between a strong base, which is sodium hydroxide, and a strong acid, which is what? Hydrochloric acid. So let's kick off. Then this is another beaker. So this is my hydrochloric acid. This is concentrated hydrochloric acid. So it's very well concentrated. You can see the smoke. Then we carefully measure 9. Before I even do this measurement, then let me fill this with distilled water, because when diluting acid, you add acid to water, not water to acid. So let me fill with water before we add the acid to the water. So okay. Be very careful here. Very careful. Nice cm cube. We are there. That's 9 cm cube. This is 9 cm cube. Then then you stir. Now, then you fill to use the distilled water. Then you fill to that mark as well, just as you did before. Okay. my solution is ready. My solution is ready for the titration. This is my solution A, which is the acid. What I just did was that I measure 9 cm cube of concentrated hydrochloric acid, that is HCl. 9 cm cube of concentrated hydrochloric acid, HCl. So I just use my measuring cylinder, 9 cm cube, I put it here. I added water first before adding the acid, then I fill it to this 1 dm cube. Then for this second one, I did, you know what I did here. So our solutions, they are ready. Our solution is ready for the titration, and we'll be using methyl orange for the titration. Okay. Okay, students, let's have the titration. Let's see what our VA will be for this reagents. Okay. So you wash your materials, your apparatus, then you wash this, then you rinse it with the acid you will fill here with. You rinse it with the acid. So I've already done that to save time. So this is our acid. So you fill the burette. This is my burette. So you fill the burette with acid. Fill the burette with acid. You fill the burette with acid. You fill the burette with acid. So let it be at 0. Okay, you take the lower minus first, so it's at 0. Then you remove the foliant. Then this one chemical flask. So this is another picture for the base. Then we have to I've already washed everything. So this is our pipette filler, our pipette bulb. So instead we don't use mouth to suck. Instead we use our pipette filler. Then this is our pipette. This is pipette. We use pipette to suck the base. While we fill the acid inside the burette, then we use the pipette. This is the pipette. We use it to suck the base. So this is our base. Let's We are using methyl orange because the titration is between a strong acid and a strong base, so any indicator can be used. So just add 2 drops of methyl orange. 1, 2. So just 2 drops. You can see it. Methyl orange in base is what is yellow. It's yellow. So this is my white tie to see the color change. So now let's begin the titration. So let's see the color change. You can see the color have changed. See the color have changed. You can see the color have changed because when we added the methyl orange it was yellow. Now this is our end point. Color at end point is what is pink. So we have, this is 22.60. 22.60. That is our end point. So you can see it. So you can see how I prepared the reagents, and this is the titration, and the color have changed. So this process is called neutralization reaction, the process by which acid react with a base to produce salt and water. So that is neutralization